Okay, and welcome back for part 2 of section 3.1. We're going to start out by taking a look at the mode. Remember, we're working on measures of center, or some text called measures of central tendency. The mode's a weird one because the mode by definition the mode of a data set is the value or values that occur with the greatest frequency. Okay? One of the only advantages I see is you can have qualitative data and have a mode. But a disadvantage is a data set could have no mode, or it could have multiple modes if there were a bunch of data points that occurred with the greatest frequency and they were all the same. So pluses and minuses. There are no mathematical calculations that I'm aware of that use the mode for calculations. We use means and medians, but not modes. Okay, how do you find them? Well, you scroll through your data set and find the one that has the greatest frequency. If two values occur with the greatest frequency, you could say that your data set is bimodal, or you could just go with multimodal. If there is nothing, if there are no data values that are repeated, you'd say that there's no mode for the data set. So these data sets we had here, nothing's repeated. We would say this has no mode. Nothing is repeated here. Again, no mode. The only way to have a mode is to have something repeated. For example, take a look at this list right here. This list, well, look, this number happens twice. So guess what? That's the mode. The mode is 235. What does that mean that the mode is 235? It means the number 235 occurred the most, the greatest frequency. It occurred twice. Does it really occur that much more than everything else that we want to single it out and say this number is important? That's a tough question to answer. Technically, it is the mode because it fits the definition. But really, if you wanted to have a mode that was meaningful, you'd want to have something that occurred frequently enough, or more frequently enough, that it truly was an important value in the data set. So if I had a, say, 50 number data set, and there was a value in there that occurred 15 times, if there was a value in that data set that had a frequency of 15 and nothing else was even close, I'd probably say, oh, that happened a lot. And it happened enough times that I would call it important. So I would call whatever that number was, I would definitely say, oh, that's a mode. And that's an important distinction to say that that is the mode. This 235, I mean, it's the mode, but I would say it's not important. All right. Last one, the last measure of center we have to take a look at is something called the midrange. Now, the midrange doesn't have as many applications as some of the others, but it does have applications. The midrange is the data value that is halfway or midway between the maximum and the minimum values in your data set. Right? So the way that we find the midrange is we take the max minus the min and divide it by 2. We call that the midrange. Right? Now, some properties of it, because it only uses the max and the min, it's really sensitive to those and it's not resistant at all. If you have outliers, well, outliers on the high end are going to be your new maximum. An outlier on the low end is going to be your new minimum. So it really messes with it. In practice, we rarely use the mid-range. Right? It does have some redeeming qualities or features. It's super easy to compute. You literally subtract 2 numbers and divide by 2. You find the mid-range. Oh my gosh, there's a typo. That's supposed to be a plus right there. You add 2 numbers and divide by 2. I am so sorry. I got it right up here. adding the maximum and the minimum and then dividing by 2. Somehow I made that wrong when I wrote that formula. I have to change that in the notes. Let me make a note to myself to change that for you. This is 3 point something. Mid-range formula. Hopefully that'll be changed by the time you download the notes. It is interesting because it does allow us to reinforce that there are plenty of ways to find this measure of the center. Be careful though, because sometimes people confuse the mid-range and the median. Right? It's possible, depending on your data set, the mid-range could have the same value as the median. That would not mean they were the same number. Okay, so here we go. Our example for finding the mid-range. Here's those Verizon data speeds. I want to find the mid-range. So my mid-range is going to be the minimum plus the maximum divided by 2. 14.1, that's the minimum, plus 55.6, divide that by 2, grab my calculator, 14.1 plus 55.6, divide that answer by 2, and we get a mid-range of 34.85. Again, these are megabits per second. Okay? Now I want to point out something. The good people at TI expected that you would want to do stats on the TI, and they built in those two. They did not waste time building in these two. That should tell you something. Okay? That should tell you that these two are important numerical calculations that we are going to use further for more things. And these two are less important values to know that we won't be using further. Right? So key takeaway should be, I need to know how to calculate these. Key takeaway down here is I should understand what they are. I'm not so much worried about calculating them. Okay? Some general round-off rules for measures of center. Okay? Some general rounding or round-off rules for measure of center. For the mean, the median, the mid-range, go 1 decimal place more than the original data set. So up here, you'll notice that this went to tenths. Our mid-range goes to hundredths. Okay. Neither of these allowed us to go 1 point further because this math just worked out perfect, and this is just the data point. So I can't do it there. But up here, when I calculate the mean, 2 data places, 2 decimal places in the mean, 1 decimal place in the data. Okay? So whenever possible, when you're calculating the mean, the median, the mid-range, go 1 decimal place further. If the math works out perfect, you can't do anything about it. Okay? If you're calculating a mode, you never round. Leave the value as is. No rounding. Okay? Because the mode is just the original data value. Okay? Now, the critical thinking side of this is measures of center can be calculated on data sets from any sample of numbers, but you should stop and think, does it matter? Does it make sense to do that? Here's what I mean by that. You ready? Zip codes for Gateway, Arch, and St. Louis are those numbers right there. Can I find the mean of that data set? Can I find the mean of those zip codes? Now, numerically, I can add those numbers together and I can divide by 1, 2, 3, 4, 5, and I can get a mean. But would that number tell me anything? Would that number have any purpose or meaning? So remember, when I'm finding values, I want to take a look at what type of data is. And that data right there, that is categorical data. those numbers aren't numbers. Okay? So even though it's numerical, I shouldn't find a mean or a mid-range or a median for that data set. Right? Well, what if I had something like this, where we have the ranks of several universities? 2, 3, 7, 10, 14. Could I find the median of that data set? Well, yeah, right there at 7. What did I just find? Does it measure or count something? Is it a meaningful number to have found that? Could I find the mid-range of that data set? By taking 2 plus 14 and dividing by 2, 2 plus 14 is 68. So I get an 8. Does that tell me anything? Well, no, because while this is ordinal data, it is ordered. It isn't, I can't do these calculations on it. So when you're thinking about measures of center and whether you can or can't do them, it's more than just, are these numbers I can add together? It's, if I add these numbers together and divide by 2, does it mean something? If I add these zip codes together and divide by 5, does it tell me something? Is that a number that I can use to predict something or to talk about the typical or average? And clearly, it wouldn't mean anything to us. All right, that brings us to the end of section 3.1. I'll see you back here for 3.2, measures of variations next. Have a good day.